Hello everyone and welcome to yet another recreation programming session with Mr. Azozin. So today we're looking into libuv, right? So it's a library called libuv, which is used for asynchronous I/O in Node.js. And this is exactly how we discovered. We had a session where we looked into how make C++ plugin for Node.js, and this is how we discovered, right? And remember on that session, by the way, I should probably put that session into the description, right? So libuv review, right? So this is a libuv review, and this is like a Node.js session, right? So I'm gonna put that like after the stream, right? Because I don't have a link to that. So and yeah, so on that session that I said that Node.js doesn't really introduce anything new. It just like glues together a bunch of pre-existing libraries. Well, I'm actually wrong, right? So the library that it uses for I/O and stuff like that, it is written by the Node.js people as well. So apparently they did in fact introduce something new. So I apologize for that. Or did they? We're about to find out that today, right? I haven't looked into that library, right? So the only thing I know about this library is what's written in the front page. It's a asynchronous I/O made simple. We'll see about that. I know that a lot of people like to confuse simplicity and complexity and difficulty, right? So maybe it is complex, right? And they actually meant easy. But we'll see. So let's go ahead and just like try to build this entire library. Show me the code. Okay, so show me the code. All right, so here it is, libuv cross-platform asynchronous I/O. And so it is written, okay. It is primarily written in C. Node.js, by the way, is written in C++, but libuv is written in C. And I suppose one of the reasons why Node.js is written in C++ is because they're using V8. And V8 is written in C++. So that means C++ was used out of necessity, not because they like it. Right, the creator for Node.js, as far as I can tell, they like C more. It's just like they didn't have any freaking choice, right? So because you have to integrate with V8. All right, that's understandable. So what do we have in here? Do they use autogen, autoconf? That's disgusting. Let's fucking build this shit. Right, so let's see how difficult or easy it is to build. Though maybe it would make sense to actually download like a stable release instead of downloading the sort of like a master branch and stuff like that. So let's actually do that. So here's the source code. So libuv has been downloaded. Libubu. So let's go into maybe a third party. So here it is, and I'm going to just grab the whole thing in here and put it in here. So libubu, let's unpack the libubu. Okay, so the libubu has been unpacked very quickly. I do respect that. In terms of configure, like, it doesn't really have the configure script ready. I suppose I have to first call autogen. But before we do that, let's actually maybe open README, and maybe there's some build instructions. Okay. So build documentation, right, so they explain to you how to build documentation, but they don't explain to you how to build the thing itself, right? So, which is kind of weird. So downloading, you can download it from distributions, right? So you don't really have to build it from the source code. You can download the distribution. And I'm not really sure, like I kind of want to build it from scratch, right? So I just want to see how difficult it is to build this entire thing. So verifying releases and stuff like that, build instructions. Oh, it does have a CMake. I didn't notice that there was a CMake. Oh, here it is. Okay, I'm sorry. I'm just being blind. Okay, let's actually build this entire shit. So this is going to be the build, and let's do the configure, the usual configure. Okay, so apparently I do have all of the necessary dependencies. Well, failed, but it's MSVC that failed. But overall, I suppose it is ready to be built. Okay, so let's actually see how quickly it is built with 16 threads. Let's fucking go. There's a bunch of warnings, right? So, which is fine. There are not errors. And it is building. It's almost done. I hope, and that's it. So apparently, that is this. That is it. I'm not really sure what exactly can I do with all of that stuff, right? So here is the libuv.a, so the static library itself. There's a package config, and there's also libuv.so. And that's about it. You know what I should have done? I should have actually set the installation prefix, right? So let's actually try to install this entire thing. So I think somewhere in a cache, there is something like a prefix. Yeah, there you go. So here's the install prefix. Let's actually maybe do cmake, and let's actually set this prefix to something like home opt libuv. So here is the libuv, and let's try to reconfigure the whole thing. So in a cache, if I reverse the cache, now it is pointing to this installation prefix, and I'm going to, just in case, rebuild it from scratch, just in case, right? So because I don't know, maybe it needs to regenerate some of the things and stuff like that. Thank you so much for the subs. Thank you. And I apologize if I missed anybody, right? So I'm currently busy with libuv. And let's go ahead and just like install this entire thing and see what does it install. It installs quite a few things, right? So, but not that many, right? It includes, installs a bunch of includes, right? It's a library. So there's a little bit of a paperwork, licenses and stuff like that, package config configuration, the static library itself, cmake scripts, and just the dynamic ones. Okay, that's pretty simple. So far, they didn't lie to us. It is, in fact, a pretty simple library, right? And like, if you look at like on outside, right? So if you look at outside complexity, it is pretty simple. Just a static library, a bunch of header files, link with it, use it. So that's pretty cool. That's already plus for me. Okay, let's take a look at the headers themselves. We're not looking into documentation, specifically to piece of, the fans of this library. Right, specifically to piece of the fans of this library, we're not looking into documentation. We're trying to look at the source code directly and try to understand how to use it just from the source code. So, yeah, so pretty straightforward. So far we have uv.h. This is probably the thing that we have to include in here. So there's a bunch of copyrights and stuff like that. It integrates with C++, pretty respectable. And yeah, I can't understand. They're using X macros. They know what is an X macro. Do you guys know what is an X macro? Do you follow me on Twitter? On Twitter, I posted like a clip which explains what is an X macro. This is amazing. Wait. Oh, it's AI. All right. So it was the recent AI boom, right? So kind of fucked up my pattern recognition, and I see AI, and I thought they built an AI into the IO library. So, like everyone puts AI everywhere. I thought they put AI here as well for a second. AI family is actually related to the internet protocol, so don't worry about that. So there's also ibusi. So, well, I mean, it's just like a different arrow, so there's nothing particularly special in here. And there's quite a few X macros and stuff like that. Okay. So that's pretty cool. You can create a UV loop and stuff like that. So as far as I know, this is literally a library that implements the event loop of Node.js. So that's what it does. Okay, so let's actually go ahead and try to maybe link with that library. So I'm going to go into liprobe, and here, where is the libuv? So here it is. And I'm thinking I'm going to create a libuv, and I'm going to just literally move this entire stuff in here. Hopefully it will not fuck up the build stuff, but I mean, it builds pretty quickly, so there should be nothing special about that. So let's actually create like a main.c, and let's literally include uv.h. Right, so I think that's how you use this entire thing. And let's try to build this entire stuff. So maybe I'm going to be using makefile for now, at least. It's going to depend on this entire thing. And if I try to build the whole thing in here, let's enable a bunch of warnings, right? So because it's always nice to have a bunch of warnings. And if I try to just build the whole thing, it's not going to build because it needs to know where all of that stuff is located. So let's actually put that somewhere here. So as far as I know, this is how we have to do that. So libuv and include. So all of that is located in opt, like so. Here is that. All right. And yes, so that builds successfully. So far the problem is that I don't really know what's going to be the next step in here, right? So what's going to be the next step? I'll probably have to look into the examples, but I suspect that the most important thing is gonna be first. Okay, so let's actually take a look at the version, right? So it provides the functions that allows us to query the version of the library. So I think it would be kind of nice to call these functions to test how you link with that, because I'm pretty sure I won't be able to call this function unless I link with the library. I can include the headers, that doesn't really require linking, but then I can't really use any functions. Okay, so let's actually do something like include stdio, and let's maybe print some stuff. So this is going to be printf, this is u, and you can say uv version equal to this, and let's just call this function directly. And there's also a string variant of this entire thing, so let's actually put something like uv version string is equal to s, and let's just simply call this entire stuff. All right, so if I try to build this entire thing, it is not going to build because it needs to link with libuv. All right, so if I try to link with libuv, luv, it is not going to do that because it can't find this stuff. So let's actually maybe update the search path somewhere here. So here is the lib, and so it cannot find that. That's surprising. Wait, it's in libuv. It is called libuv, right? Libuv, and usually you can just do that. Maybe we can directly tell it what to link with, right? So libuv.a. So that means it's not here. Just a second, chat. I think I'm having... of course. Of course. Of course. 64. I apologize, right? So of course I'm on a 64-bit machine. That's what I have to do in here. Okay, so if I take a look at the dependencies, there should be no dependencies because I actually linked, you know, statically, which is nice, right? So I think statically linking with libraries is good usually. Okay, so that's the version. I have no idea what that's supposed to mean. So it is. What if I take, like, what is this version? Excuse me. Is this? Do I have to look into it in hex? Maybe I have to look at it in hex. Just a second. So if I try to rebuild the whole thing in here, why doesn't it look? Maybe it is 33 in hex. What is 33 in hex? It is 51. Ah, that is very interesting. So that's how that's a really funny way to do that, but I mean, sure. So it is like, so then you can easily extract different components of the version, right? So unsigned int, and this is your version. So, and essentially how you can extract the patch number, right? So let's actually try to do that. I think it's going to be interesting. So the patch is going to be something like, it has to be you. So you take a version, and here is your patch. This is the patch. So then you have to extract the minor, and the minor is going to be like, you have to shift it by 8, and that's going to be your minor, and a measure, I suppose, is going to be by 16. So that's how you do that, and there you go. Here is your patch, which is 0. Here is your minor, which is 51, and the measure is 1. It's just a, yeah, you can probably cast it to a byte array. I agree with that. So, but it's kind of an interesting way to do that. Okay, so sure. So already figured out how to check a version. I can already respect that. So, and here's the bunch of definition of the functions. And the next thing, they suggest you to shut down the library. So if you just look at the header, right, and look at the definitions in a header order, the first thing they suggest you is to check the version and then shut down the library. Honestly, I respect this. just check the version and shut it down. All right, so let's actually follow the suggestion. Okay. I'm joking, by the way. It's not like I'm defining things in my libraries in an order of like importance. Maybe I should, by the way. As I'm reviewing this entire thing, I'm making mental notes for myself. I think in my libraries, I should actually kind of start sorting things in an order of importance, right? So if somebody's going to be looking at the libraries like I do at the libraries, I should order things so it kind of makes sense and it teaches like how to use the library in the correct order. So this is actually kind of important, I think. But anyways, so let's actually remove this entire shit. We don't really care about this entire shit. What I want to do, I want to actually just call this function and see what's going to happen. And nothing really happened. At least it didn't segfault, which is kind of cool. Okay. So there's a replace allocator. So I suppose it allows you to customize the allocator functions, right? So we're going to be using the default one. And there is something called default loop. Okay, that's very interesting. So maybe we can create something like this, right? So it creates a default event loop. And I suppose I have to save this entire thing somewhere here. Let's go ahead and just like check. If I try to create a loop, right, it's semi-zaloop. What is going to happen? Is it going to give me something? Right, is it going to give me something? Let's actually see. All right, so yeah, you're not supposed to actually put in here. Okay, it gave me some sort of a pointer, and I wonder, is this pointer even is this type even like a transparent type? Can I even take a look at the definition of this type? I don't really see the definition of this type. I feel like, yeah, I feel like it is an opaque type. Wait a freaking... No, it's not an opaque type. Okay. So that's pretty cool. But there's a lot of like an internal stuff in here. And there's some private fields. UV loop private fields. How do you define private fields? Are they defined somehow? I don't really see the definition of UV private fields. I suspect, by the way, that this is defined as sort of like a array. Like a padded array of bytes, right? So there's some size to it, but you can't really know what it is, right? So you can't really know what it is. Okay, let's actually try to search for this entire thing in here. So here's the definition. Yep. Really? You expose the private fields to the user? Well, I mean, maybe that's fine, right? Maybe that's fine. So just the fact that they are behind this macro already tells the user that, okay, use these things on your own risk. There's no really reason for a C developer to hide the structure from another C developer, because we treat each other as, you know, professionals. We're not JavaScript developers, we're C developers. But at the same time, like it's kind of nice to inform your fellow C developers that, hey, this kind of stuff may change at any moment, so use it on your own risk. If you use any of these fields on the next release, on the next version, probably your code is not going to work. Okay, so that's actually a very cool approach, I think. That's actually a very cool approach. But anyways, okay, so we created the loop. And what else can we do with that, right? So it didn't block, it just created the loop, right? It just created the loop. And I also remember there was something like init the loop, right? So do I have to pass this thing to init the loop? And why default loop didn't init itself? That's another interesting question. So let's go ahead and try to maybe init the loop, right? So we're initializing the loop. So here is the return, and let's actually see if return returns anything. I suspect return just indicates whether there was any error during initialization of the loop, right? So let's actually see. So this one is going to be equal to z, right? So here is the return. And so let's just do the build, and it returns 0. So I'm going to expect that 0 means everything's okay, right? So 0 just means everything okay. And then you can close the loop, right? So you can close it. Let's actually see what is... Okay, so we managed to open and close it. Now let me see. You can delete it. That is very interesting. So you can close it, and well, it's deprecated. Okay, it's fine. So there is a little bit of a deprecation API going on, right? So this function is deprecated. User should allocate loop manually and use UV loop init instead. Allocate it manually. But what's the point of UV default loop then? That is fascinating, but anyway. So close to the memory and stuff like that. So you can take the size, you can check if it's alive, you can do configuration, which is also very addict. You can fork the loop. And finally, you can run this motherfucker. This is what I was looking for, actually. Like, I created some sort of an event loop. Okay, how do I start it? How can I make it loop? Right, so finally, this is probably how you do that. So, and it has apparently several modes. Okay, so you can do the default mode once and no wait. Have no idea what the fuck all of that's supposed to mean, but let's fucking run this function. I don't give a shit. So I suppose, you know what I want to do? I want to just try to take the default one and do not do any initialization or anything like that, and just call this entire thing. By the way, so the default one is 0, right? As we saw in the in the definition, right? So default one is 0, which means that maybe you can put a 0 in here, and I suspect that the reason why you even have a default loop is that you can quickly create like a default loop like this. There you go. I think that's what it's for, right? So if you just want to quickly start the library, just do that. This is my hypothesis. Like, again, I'm using this library for the first time, like I don't know what the fuck I'm doing. Maybe I'm terribly wrong, but this is what it feels like. So obviously you can customize your loop, you can customize where you allocate it. Maybe you can allocate on a stack, maybe on a heap and stuff like that. But sometimes you just don't give a shit. So here's your default loop, just start it in whatever default mode, and there you go, you have some sort of a loop. And if I understand everything correctly, doing that should just block the application. Right, it should just block the application and shouldn't do anything. And since it's a async IO library, we probably have to set up some sort of a callbacks, right? So maybe there should be some sort of a timers, right? So if this is a good IO library, there should be a way to say, okay, maybe there is a set timeout for a particular callback, start an event loop, and expect your function to be called in like 5 seconds or something like that. So this is what I'm predicting, right? So this is what I'm predicting. Let's see if my predictions are correct. Okay, so, and it didn't block. Look at that. UV run didn't block. So that means I'm completely wrong on all of that shit. Like, I'm completely fucking wrong. But we haven't checked what was the result. So let's actually see. So this is a UV run, and UV run in our case returned this entire thing, right? So if I try to, it returned 0. So nothing happened at all. All right. So what if I try different modes in here? So there's a UV run once. Maybe I'm supposed to do that in a loop myself. Maybe I'm supposed to organize the loop. So if I try to use no wait, right, if I try to use no wait, what is it going to happen? Okay. So my hypothesis is that maybe run just means that I have to run it myself. Maybe I just have to run it myself. Okay, so I want to try to call this entire thing several times. So this is a UV loop T. UV loop T. So here is the loop, and I'm going to just take a look at this entire thing. And let me, so I think I'm going to pre-allocate this variable in here because I'm kind of reusing it several times. So what if I call this function 2 times? Right, what if I call it 2 times, right? Is it going to break, or is it, nothing really happened, right? Nothing really happened. Right, so my hypothesis, my working hypothesis so far is that maybe you have to organize loop yourself, right? So essentially when you already run one single iteration, do some other thing between the iteration and run again. Maybe that's how it's supposed to be done. But anyway, let's continue looking. So you can also stop, right? So if you're running yourself, what's the point of stopping, right? So that kind of doesn't make any fucking sense. But here is an interesting thing. What if I insert the stop between these 2 calls? What is it going to happen, right? Is it going to successfully run the second iteration, or is it going to stop? I don't really know. And UV stop, by the way, doesn't error out, right? It returns void. So, okay. Let's go ahead and just, nothing happened. Nothing happened. Okay. All right, so there's different things like UV backend timeout doesn't really tell me. So you can update time, doesn't really tell me anything. There's a bunch of callbacks in here, nothing particularly interesting either. So callbacks. So there's some sort of error. I suspect that's totally fine. You can do UV shutdown. So let me see. Is there something like a timer? Okay, there are some timers in here. Okay, so there is a UV timer. You can just create a UV timer. How do you even create that? Okay, so you can initialize a timer. And I suspect, like, you have to provide the loop. And basically, I think the loop in UV context is the context of the asynchronous library, right? You remember how we did async.io? Not async, ASIO, right? So basically ASIO, and it had its own context. So here it also has its own context, and that's probably loop, right? So we have to create a UV timer. I suppose we have to allocate it somewhere on the stack, initialize it, then start the timer, and we have to provide the callback, right? So we have to provide the callback. So let's actually test my hypothesis that I have to do this kind of thing in some sort of a loop, right? So I kind of want to try to guess at least something correctly, right? So guess at least something correctly. So here's the UV timer, right? So here is my timer, and I'm allocating it on the stack, right? Allocating it on the stack. So now, if I try to find the definition, maybe there is something like a struct UV. Oh, here it is. Maybe that's what it is. So there's like a handle. Oh, they have a little bit of a inheritance in here. You guys know what it means? Right, UV handle, so it inserts the handle field. That means there is a superclass for the timer. It's OOP. They are literally doing C++ style OOP. Not only OOP, but I think they also can do multiple inheritance if you think about it. So let's actually find all of the fields. Can a single structure includes several fields from several things? Okay, so there is a shutdown structure, and it has a request fields. So that means there is a superclass reflect, and there's also, they use that for private fields. Is there any structures that actually inherit more than one thing? So maybe it includes request field. It's kind of difficult to pull off, right? So to make it sort of castable, to make the pointer to shutdown castable to request, it has to be at the top. Right, if you do multiple inheritance, like you can't really do that, because to be able to cast it to a certain thing, it has to be at the beginning. But if, okay, so I'm actually going crazy. So if you have something like foo, and you wanted to sort of inherit both bar and buzz, right? So you can't really do that by the same logic, right? Because to reinterpret pointer to foo as pointer to buzz, buzz has to be at the top, but you kind of put it in here. But then you can do a very interesting trick. If you want to take a pointer to foo and reinterpret it as a pointer to buzz, you have to find the first field of buzz and take a pointer to that field. So you don't point at the beginning of the structure, you kind of point in the middle, and that kind of casts this thing to buzz. Union. But I mean, no, what if you don't want it to be a union of these two things, but what if you want it to be two things simultaneously, right? What if it has to be bar and buzz simultaneously? So it has to include both of the fields. But maybe there is not that much use case for this specific thing. But anyways, so I just wanted to see if there is anything like that. Right, so far. There you go. So there is a thing that is simultaneously handle and a stream. Well, I mean, the stream, it's already a stream, right? So, okay, so maybe there's some other things in here. So there's a request. Here's another thing. There is a thing TCP, and it is simultaneously a handle and a stream. There you go. So multiple inheritance. It is in fact a multiple inheritance. But then how do you like take a pointer? Do they have some sort of a machinery, some macro machinery that allows you to reinterpret this thing as pointer to a stream? But anyway, So let's actually continue. So here's the timer, and I suppose we have to provide the loop, and here is the loop. And I also have to do something like this, right? So I have to initialize the whole thing in here. So here is the return, and then I want to print the whole thing like that. So this is going to be this, and I want to see the result of this entire stuff. Okay, so let me just run the thing like so. So printf, it didn't like printf because implicit declaration of printf, didn't I? Printf. Okay, so that happens. Okay, so initialization of the timer went well. I'm super happy about that. So here's the uv.h. The another thing we have to do, we have to start the timer. Okay, so I provide the timer handler, right? So here's the timer, and I have to provide the callback, right? So where is the callback? Where is the definition of the callback? So this is how the callback should happen. It accepts the timer itself, I suspect, right? So it accepts the timer itself. So let's call it fire, and here it is. So we're gonna do something like this, boom, boom. And what I'm thinking is that, what if we're gonna do the following thing? So this one is going to be fire. And here is another thing. What is the timeout? Is it in milliseconds or is it in microseconds? So it's kind of interesting because it's uint64, so that means it's expected to be big. It is in fact expected to be big. Right, so let me find this entire thing, and the timeout, there is nothing much about the timeout. Is there any helpers to define you different timeouts? Okay, so here's the timeout. Right, so here's another one. And no, there's no helpers for all of that stuff. So here's the time. Maybe there is some stuff in here, something about time. No, let's do grep. Let's do timeout. Okay. No, and there's no explanation anywhere in the source code of what it is. I'm pretty sure there's some explanation in documentation, but it's boring. Let's not look into documentation. Okay, so I'm gonna assume that it's milliseconds, right? So we're gonna make a wild assumption that it is in milliseconds because it's, after all, it is used in JavaScript, and JavaScript, like I said, timeout is in milliseconds, so whatever. Repeat, I'm not really sure why repeat is uint64, because it feels like it's a boolean, right? Just by the name of this argument, it has to be a boolean. So let's just set 0 to that. Okay, so, and in here we got the return. So let's actually print the result of this entire thing. So this one is going to be timer start, and let's just see if it started correctly, right? So we're going to do some, okay, so that didn't work. I should do something like this. Wait. I don't have to organize the loop. It organized itself, but since it didn't have any jobs, it instantly quit. So to make it not quit, I had to have some jobs. Absolute budgeting. So yeah, I figured it out. So all the people who are currently crying in the comment section on YouTube, "You didn't read documentation, he doesn't read documentation." I dab on you. I fucking dab you. Noobs, 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 dab, 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 dab. We're gonna look into documentation when I get stuck. Like, I'm pretty sure at some point I'm going to get stuck, right? And in that case, I will look in documentation. So anyways, let's actually try to repeat, right? This is a good idea. Let's actually try to repeat that. Oh, it's kind of weird, isn't it? So maybe it is not milliseconds after all. I feel like this could be microseconds. So it's a micro, just like your PP. So let's try to actually multiply by 1,000. No, it's kind of too much. So in that case, it's a... Okay, so let's do the following thing. Let's do 5. This is probably a timeout as well. It's not exactly, it's not a boolean. So they have two timeouts, the timeout for the start before it fires, and how often to... That's a little bit bizarre, but I mean, okay. So what's the use case for having two timeouts? Right, so essentially, like, let's put thousands in here, right? So let's put thousands in here. And yeah, so it's 5 seconds, wait, and then it is going to boom, boom every second. Okay, okay, so it's just like a firing up every second. Kind of interesting. All right. So 60 FPS game. Ah, it's for the game, so that like you give a little bit of a timeout for the game to initialize, and then you start the game, and then you have to adjust this timeout so it doesn't, you know, start too quickly. And a very web solution, I gotta say, a very web solution. But anyway, is there anything else in here? Is there anything else we can do in here? So anything with sockets? Okay, so there's something with le sockets, socket pair. Okay, nothing particularly special. So poll init socket. So can I just listen? Okay, UV listen, but you have to create the string. Okay, so I want to create an echo server. Right, so I want to create an echo server, and how we're going to even approach this entire stuff. So maybe I need to, yeah, maybe I need to sort of like refactor this entire thing. So, for example, if error happens, I wonder, like, how can I trigger an error? What does it return in case of an error? Like, I'm really curious. What if I provide something incorrect? How can you provide something incorrect even? Maybe if I do -1 and then cast this entire thing to 64, maybe it will error out in that specific case. Nothing really errored out, so yeah. But anyway, I suppose one thing we can do is just like not equal to 0, right? So it's not equal to 0, and in that case we have to print something. And I do, by the way, remember that there was something like str error. There you go. And it accepts an integer, and I suspect that maybe that's what you have to put in there. Right, so let me actually show you. So essentially, yeah, so here's the error, right? So this is the error, and if it's not equal to 0, right, if it's not equal to 0, we have to just say error, maybe timer init, and just put s in here, right? So, and this one is going to be essentially vstr error, making a wild assumption, super wild assumption. So right, but it kind of makes sense, doesn't it? Right, so it kind of makes sense. So and probably want to repeat this entire stuff for all of these things in here, right? So essentially now this one becomes error. Want to put it like that, not equal to 0, and just like here. So something like this. Maybe it would be nice to kind of put that behind the macro, right? So put that behind the macro because it's kind of annoying to do all of that stuff. So here's the error. Here's another one, and so not equal 0. And let's do this stuff. UV run. All right, so does it build? Does it even build at all? So timer is not used, that's totally fine, nobody cares about that. What else do we have in here? Yeah, I forgot the parentheses. Okay, so everything seems to be fine. Everything seems to be fine. How do you like my code style, by the way, chat? How do you like my code style? It's pretty cool, right? So we have an error, you check if it didn't succeed, and then I pass it in here. It's just like very sleek, very nice code style. Feels like Go, honestly. Kind of feels like Go. But anyways, so we need to do UV listen, right? So that's what we want to do. UV listen. We're probably going to put that somewhere in here. But here is we have to provide a stream. We have to provide a stream. How can we even create a stream? So I remember there was something about TCP. There you go. Here's the thing. And if you take a look at the definition of the structure of le TCP, it is also le stream. But again, it's stream, but after the handle. How do you even get the pointer to the stream? So that's a very interesting question. So anyways, let's actually find all of the functions that accept UVTCPT, right? Is there anything? There we go. Here's the initializer, right? So this is how you initialize. Isn't it cool? Here's the thing. Remember how I was trying to use SIO, ASIO? Do you remember this struggle? Here, I'm just walking through the header, looking at the declarations of the functions and types, copy-pasting the chunks, and I'm just using it. There's something here to say about simplicity, but I'm pretty sure C++ fans are not going to listen to me. I don't know, like I'm not only saying, just saying things about C and simplicity and how simplicity is important. I'm also showing you. And a lot of people just like present it with evidence, still reject it. So many people reject the reality. It's insane. It's insane. Simplicity. That's the key to good software, right? Haven't opened documentation a single time so far, streaming for almost an hour, 50 minutes, almost 50 minutes. Haven't opened any documentation. Well, I'm pretty sure we're gonna open documentation at some point, right? So, but I mean, so far, everything's fine. But we need error AI. In some cases, you do kind of need error AI, and error AI is kind of useful, but I think like things like defer kind of make it obsolete, honestly. It's a simpler solution to what error AI is trying to solve. And in here, we don't even need error AI, right? So we can just pre-allocate a fixed amount of resources up front and just use this fixed amount of resources. So in that case, error AI only adds complexity. What is error AI? It's an abbreviation that stands for Resource Acquisition is Initialization. It's an idea that you have objects in its lifetime, for different phases of its lifetime, you have specific callbacks, specific functions that are called, namely constructors and destructors, right? So when this object comes into the lifetime, comes into scope, a constructor is called and initialized and stuff like that. When it comes out of the scope, a destructor is called. So that's basically the idea of array AI. Right, so you have an object, you have different phases of the lifetime of that object, and with each phase of the lifetime, there is a function associated with it, so you can put things in there to keep, the state of your program correct or something like that. So that's basically what it is. But in reality, it adds more complexity than it solves problems, in my experience at least. Right. But it is useful in some cases, right? So it is useful in the cases when you need to like allocate some stuff and then deinitialize when you exit the function, like exit some scope always. And for this kind of stuff, a lot of languages actually invented defer, right? For this specific stuff, defer was invented. It is used in Go. It is used in modern languages. I think like Zeek and Odin also use defer. It's just like Jai uses defer. And as far as I know, defer comes to C as well, right? So a lot of simpler languages, not OOP languages, are trying to introduce defer. Anyways, so yes. Simplicity is the key. Simplicity is the key, I believe. But anyway. So here is the TCP, and I suppose we have to just initialize the TCP, right? So let's just initialize the TCP. Here's the pointer, and we also have to provide the loop, right? Here is the loop, and in here, let's actually assign this entire thing in here, and let's wrap it like that. If it's not equal to 0, we have to grab this entire thing in here. There we go. UV TCP init. Init. So I wonder how it is going to go. So let me see. So I forgot some parentheses. Okay. So if I try to run the whole thing, it didn't fail. Right. So it didn't fail. So that means it initialized the TCP correctly. Okay. So listening. And here is an interesting thing. If I just take the pointer to TCP, I suspect that it's not going to be, it's not going to work, because the pointer to TCP is not equal to the pointer to UV_stream_T, as I already said. So let's take a look at the definition of this thing. So it is somewhere in the structure. Oh, wow. You sneaky son of a... You sneaky look at that shit. You mother flipper. Fuck you. Okay. Okay, read the comment. I don't read documentation. Fuck you. That's so cool. So, and okay, so they explain that it is a substream. Okay. So, I see. So you can just like, they will make sure that all of these things are compatible with each other. Okay. Look, for real, who needs C++? Like C++ on a low level, when you do inheritance, it literally does that. It literally does that. Like, look at this. It's amazing. It's fucking amazing, bruvskis. Just keep the fucking order. Yeah. And so here's the parents and stuff like that. And it's even syntactically simpler. You may make an argument that C++ simplifies all of that stuff with a nice syntax. Not even syntactically, this is simpler than C++. Syntactically! To be fair, at this point, anything syntactically is simpler than C++, but that's besides the point. Anyway, so here what we have to do, wait, I think I did the fucky wucky. Did I do a fucky wucky? Did I do a fucky wucky? I think I did the fucky wucky. Yeah. So here we have to put the TCP. Though I'm not sure if the compiler will like me just passing the pointer to this so easily. So in terms of backlog, let's put 69, right? So here is the le69. And in terms of conniptions, so here is the conniption. Okay, so the conniption callback. Okay, so connected. Let's say client connected, and it even accepts le server, right? It accepts le server. And here, what we can do in here is, so yeah, it is connection CB. Okay, so connected. So yeah, so did I call client connected? Client connected. Okay, client connect. And I suspect, by the way, web server or application server. So I think in our case, we're going to be doing application server. So this is definitely not going to be a web server, right? So because we're not doing HTTP or anything like that. So it's an application server. So this is going to be error, right? So it's going to put it like that, not equal to 0. All right. So honestly, I still don't know what's the difference between web server and application server. I should rewatch that video, to be fair. I should rewatch that video to familiarize myself with the latest technology in the field. So let me see. So the status, all of that stuff is not really used. Server and status. Okay. And what do we have in here? Yeah, this is what I'm talking about, chat. This is what I'm talking about. So see, in that regard, like you can't just do that. You have to also cast the pointer to a specific type. You have to sort of like a forced cast. But one thing we can do is that we can cast it to void star, right? So because you can implicitly cast void star to any pointer, right? To any pointer, and you don't have to think like what you're casting to, like you don't have to think about, and that works. So you have boom, and you kind of expect a connection, but we never specified what we're listening, right? So C++ people are crying right now. Yeah, we never specified the port or anything, like at least even a port. So yeah, that's kind of weird. Usually when you create TCP sockets, you initialize the socket, you bind it. I remembered, you have to bind it, probably. You probably have to bind it. Okay, so bind, TCP bind. Okay. There fucking go. Listen. This library already deserved a star from me. I fucking love it. I fucking love the fact that I'm just messing around and I can understand. This is already a star. Okay, so I already like this library. This is a good library. Okay, that's pretty cool. Okay, so here's the handler, and I suppose we have to put a TCP in here, and again, probably void star. So, and this is structure. I suppose it's a structure that also defined in here, right? So, where is it defined? Oh, fuck. Kok soy spiste. Okay, grep_rn. Okay, I hope it is defined in here. I hope it's not from the standard library. Please, don't be from this. I feel like this is the shit from the okay. I think this is the shit from the standard library, and we'll have to initialize all of that stuff. So it's a POSIX 1. Fuck. Okay. So, I hope I don't have to. I hope I don't have to, you know, use the POSIX functions to fill in the structure because it's anal. Anyway, let's fucking go. Maybe there's some helpers that help with all of that. Is there any helpers? Any helpers? So TCP connect. TCP connect. I don't remember how to. Wait. So the get info. So you can do that. UV interface address. Oh, so, all right. So you can base. This is nice. Just a second, chat. Just a second. So essentially, what you're telling me, Brabziki, is that I can do something like 27001 and then 69 and then I can just take the address. Address in. I probably have to allocate this specific thing like in. So the POSIX socket address stuff, it also has a little bit of a C++ style inheritance, right? So the abstract class is a sock address, and this is specific like implementation of it. So we'll probably have to allocate this specific thing. And of course here, this entire thing can fail, right? So let's do something like that. So not equal to 0. Right, and I hope it is actually allocated properly. IP4 ADDR. I kind of want to test this entire thing. You know what? I'm going to build with GGDB, right? So we're going to have a little bit of a debug information, and I want to put a breakpoint in here. So this is going to be awesome int3, and int3 is an instruction that throws like some sort of a trap signal. I don't remember. It's just like basically triggers the debugger. A lot of debuggers actually catch this this interrupt and put a breakpoint in there. 3-bit int. Is it 3-bit? I don't know. Okay, so let's actually try to build this entire thing. So it seems to be building, and I'm gonna do gf2, and I'm gonna just run the whole thing. Okay, so this is what we have in here. So let's take a look at the internal structure of this thing. It is completely zero initialized. Now, if I try to call this thing, okay, so here is the port, but it's probably in the network order. So here's the address, right? So we want to probably take a look at it in hex. And yeah, so that looks like 127. Yeah, so probably. Yeah, so 7F. Yeah, so it's 127. So it's in a reversed order like this. All right. So, okay, cool. So. Even though they're using the POSIX ones, they provide a little bit of a helper functions too, so you don't have to deal with the anal POSIX IP. I respect that. But anyway, so here is the TCP, and we also have to provide the address, which we're binding in here. I suppose we have to do something like this, and then it's just like a void star. In terms of flags, I'm not really sure what kind of flags we have to put in there. So here is, okay, here is the flag. Okay, that's definitely the one we want to put in here, right? Reuse port. So essentially there's a problem on Linux, maybe not only on Linux, maybe on Windows, is that if you don't close things properly, you won't be able to reuse port for a little bit, so it's kind of annoying. So this is definitely the flag that you want to have in here. So here is that, and so if this thing is not equal to 0, right, so we're gonna report a failure. Reuse it's a reuse address. Oh fuck, it's the wrong one. I'm sorry. I don't know what I'm talking about then. But I put it just in case. I just put it just in case, right? So GCP bind. All right, so we can do listen. We're listening to 6969. So that's already a server that listens to conniptions, right? So it already listens to conniptions. This is not what I want you to do, right? So let's just put this stuff in here. Okay, so it's doing boom, 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 boom. I want you in my room, and probably also listens to connections. Let's actually see. Telnet, localhost 6969. Motherfucker, how can I double star this thing? How the fuck did I figure all of that out without any documentation? And it just fucking works. None of the bullshit. Like, listen, watch Azure stream. Literally watch Azure stream, compare that to Azure API, and tell me that it is better. Anyways. Azure stream. Yeah, but by the way, just a second. Do I have this thing? Yeah, so here is the Azure session. And by the way, I forgot to provide the link to libuv. This is amazing. This is fucking amazing. And by Azure, I mean Azure C++ boost thingy. It's just this one. Yeah, is that on the boost? It's not really an official one. Not Azure, but just C++. And to be fair, I have nothing against this library itself. I feel its complexity coming from the fact of using C++. Right? If it was not a C++ library, it would have been simpler. But I mean, it's just C++ kind of tempting you to use more and more of its feature until it just like kind of turns this into this bloated mess. So, and yeah, anyway, so that's this thing. And libuv is much simpler. Libuv is much simpler. Anyways, so yeah, we were able to make a conniption, right? So we're able to make a conniption, but it's unclear how the fuck do you accept a conniption, right? So here is the, you listen, and it calls this, there must be some sort of a UV accept where you pass a server and there must be UV accept. Consistency of the API, UV. And it even has a name, server, and here you have, man, fucking, anyway. So I suppose what we have to do, right, so we probably have to allocate this entire thing somewhere, right? So this is a client, we're going to allocate it in stack and zero initialize it and stuff like that. I'm going to pass this thing in here, and I'm going to pass the server in here. So save this stuff into error, right? So this is going to be my error, and this stuff is going to be not equal 0, something like that. Print f error. I'm not really sure what we're going to do in here. Right, so this thing doesn't really allow us to error out easily. I want to use this library for something. I kind of makes me want to really use it for something. Okay, so UV accept, and it was a str error, so it's going to be s like so, and I suppose we just return, right? So we can just report an error. So this function doesn't return anything, so you can't really report that error anywhere up there. So yeah, you can just only report it in here and quit, I suppose. So maybe, yeah, everything's fine in here. Okay, so we managed to accept. Now I want to try how it is going to work, right? So this is a status. Okay, so it's booming. It is booming. And now if I do telnet 69, okay, that's very interesting. So server loop is not equal to client loop. I see. So when you're creating the stream, you have to initialize this thing, you see? And you initialize it with a specific loop. So that means you need to have an access to this loop. But in this message, they actually said that you can have an access to the loop. It's literally server loop. So that means I can probably do something like this. I can do TCP init, just initialize the client with the server's loop, and the server's loop probably refers to that default loop that we created. Okay, so, and we can just do something like this, so that should make sense. And yeah, in case of an error, right, you probably have to deinitialize it, otherwise you kind of leak in a little bit of a memory. So we'll have to think how we can do that. Maybe we can like employ a little bit of a defer as like go to as defer approach. Though latest C++ kind of introducing defer, but I think they didn't really accept it yet. TCP init. Okay. Dinit. Yeah, so we'll have to call dinit. So this is the client, and yeah, it has to be void star, right? So this is what we're doing here. And let's do the conniption, and it connected, right? So that's pretty cool. So yeah, in case of an error, we have to deinitialize this entire thing. So TCP dinit init. How do you do? Maybe TCP close. I suspect close reset. TCP init. Yeah, they don't have any information in here. TCP bind, TCP. This is the only candidate that I can see in here that might be actually related. Bind, close. Maybe it's close one. Shutdown. Maybe it is shutdown. Just a second. TCP shutdown. No, it doesn't exist. So shutdown. But anyway, whatever. So we accepted the connection, right? So now I want to send something to the client. Maybe on the parent side. Maybe stream close or init dinit. So UV stream. Probably even accepting. Yeah, there we go. So there's a bunch of things. Ah, I see. So this one is interesting. So I suppose you kind of call a shutdown request. So you can't really easily shut it down. You have to send a request. Okay, so I'm gonna just like copy paste this entire thing and investigate it a little bit later, right? So this sounds interesting. But for now, I want to send something. And maybe you're, by the way, sending through a stream. Maybe you're sending through a stream. Oh, fuck you. I fucking hate you. I'm so sorry. Okay. And you have to organize a request, right? So you have to organize a request. It has a system of requests. It has a system of requests, and let's see. So this is the structure, right? So here's the right structure. Okay. Yeah, and it's a request fields. So that means there should be something like UV request, or maybe just rect. Yeah, so it's a rect. And if I take a look at the request, so is there any like a function, functions? Set data. Do I have to initialize? Okay, so you can cancel a specific request. So you can get the data. Okay. Don't really see much. Right, don't really see much. So I suppose maybe you have to work directly with this kind of request. Yeah, you can. So you write it there. Not really sure what's the point of this requesting. What's the point of this requesting? Do I just allocate it on the stack? Right, do I just allocate it on the stack like so? Right, so here, there you go, I allocated it on the stack handler. I probably have to put the client in here, right? So here's the client, and here's the buffer, right? So I have to provide some sort of a buffer in here, which is rather interesting. So what's that buffer? What's that buffer? What's the definition of this buffer? Okay, so it is not defined in uv.h. Grep like this. Okay, so any type defs. Okay, so here it is. It is a okay. That's pretty based. Like, I mean, literally, it has a base, so it's it's kind of based. So it's a sized, it's a view, right? So it's essentially a view. Is there any helpers that let me construct this entire thing somehow? Is this any helpers? So the private fields and stuff like that, private fields. Okay, so I feel like maybe I'll have to construct this entire thing myself. Understandable, understandable, understandable. So, and it's actually several of them. Wait a second. Ayuvek Zozin. Ayuvek. It's Ayuvek. Ayuvek? Oh, maybe cast to struct Ayuvek. Ah, I never worked with this API. I kind of vaguely remember this API. Uh-huh. I remember this API after working with Wazi. You know, the POSIX for WASM. Right, but I never really directly worked with these things, I think. So the intentionally... This is a interesting... It is obvious that a lot of thought was put into the design of this API. Okay. If this shit is designed by Node.js people, I have a huge respect for Node.js people, honestly. This is fucking awesome. It's just like, yeah, so they put a lot of thought into the design of the API, into like... I really fucking like that. I really fucking like that. Helpers in main header. Ah, there's some helpers in main header. I kind of missed that. All right, so Ayuvek, what was the function? It's kind of difficult for me to find that super quickly. How are they called? How are they called? Right, it's like I can't find them right away. So I can't find them right away. But anyway, so we need to create some of these things. So this is libuv. And for the base, let's actually put something like hello. Right, so this is hello. Maybe I'm gonna put even new line. Right, so this is 6 characters plus 7, and Unix, there was a len. All right, so this is the 7 characters. So this is what we want to put in here. And I'm gonna take the pointer to the buff, right, to a single buff. We don't really have several of them. Something like uv alloc. I don't really need to allocate it if I just put it on the stack, though I feel like leaving this motherflipper on the stack is kind of dangerous. You know why? You know why? Because it's asynchronous. It's all asynchronous. So this is like the lifetime problems, right? So we're gonna basically set up all of these things and we're gonna forget about them. We're gonna go outside of the scope. And we kind of needed to survive. So because of that, probably these kind of things need to be allocated on like on a heap or something like that. Yeah, that's one thing we'll have to do in here. But I want to put like 1 in here. And there's also write callback, which I can't really access in here. Here's the write callback, and there you go. You get this request, right? So you get this request that you probably, you know, created in there, right? And inside of this request, you will probably have some interesting fields, right? So here are the fields. Yeah, so different handler and stuff like that. So maybe that's what it is. Not really sure what to do with all that stuff. UV buffer init. Oh, okay, that's what it's called. UV buff init. Okay, so pretty cool. So what does it do though? Does it just create this structure for me? Why do you need to have a function for that? It could have been a macro, honestly. Could have been a macro. Just a second, chat. It's kind of sus in my opinion. It's kind of sus. libuv. Let me take a look at the whole thing. What's the point of this function exactly? Okay, so where is it defined? Init? What was that? Forgot. The buff t. This is because I have to take it into. There we go. So here's the function. Here's the freaking. Very useful function. Cool. Anyways, thank you so much. So write callback. Write callback. I wonder if I can just put null as a write callback. That's a very interesting question. So, and yeah, so essentially this entire library is a callback hell library. But I mean, it's a nicely designed callback hell library, right? So I'll give them that. But yeah, so no coroutines nor anything, right? So you just have to do that old-fashioned style. But anyways, so let's actually start doing this kind of stuff. So this is the request. I wonder if I have to deallocate that request, like kill that request and stuff like that. Maybe there are some functions that allow you to allocate requests and everything. So here I'm gonna print something like done, like so. And I'm not really sure what to do with all that stuff. I'm pretty sure like I have to do with something with all of these things, right? So because it doesn't really manage the memory for me. Right, so let's put the status in here. And here is le callback. So let's call it write CB. Right, so this is a write CB. Let's put this write CB in here. Okay. And obviously this entire thing can error out. This entire thing can error out. Yeah. Not equal to 0. And I kind of want to make a small break, chat, because I'm kind of running out of steam, if you know what I mean. Running out of steam, and I would like to have a little bit of a cup of tea. A little bit of a cup of tea. So let me see if this entire thing still compiles. Right, does it compile? Let's go through compilation errors and stuff like that. Forgot the semicolon, didn't spend 3 hours debugging though. So this one, what do we want? So parentheses didn't balance parentheses. Yeah, happens. And here's the status, and we don't really use the status yet. Right, hey, fucking Emacs, just why are you so fucking slow? I'm typing faster than Emacs is reacting to what I'm doing. Anyway, so I suppose it's going to reply with hello every time I connect, but it's not going to disconnect or anything like that. So let's give it a try. What the fuck, Emacs? Stupid ass Emacs. All right, so this is gonna be that, right? So does it booming? Is it booming? Okay. So I'm gonna try to do telnet, and I got hello, and it probably leaked a bunch of memory, by the way. It probably leaked a bunch of memory. Surprisingly, again, like I allocated all of these requests on the stack. Absolute budgeting, by the way, absolute budgeting. Figure that out all by myself. This is amazing. This like huge props to the creators of the API. It's very straightforward, right? So it's still in this style where, you know, it's a bunch of callbacks. So you're kind of doomed to have a callback hell. But there's nothing much you can do with C unless you implement your own kind of like coroutines. And coroutines in C is also its own kind of hell, right? So it's just like you have to choose whether you want to have like a C coroutine hell or you want to have a callback hell. So I suppose things like libmil and libdeal are kind of like a good variants of coroutine hell. And I can't even open this entire thing, but you guys know what I'm talking about, right? So libmil and stuff like that. And I'm gonna put like libmil session in description, right? So I think it's also worth watching. Libmil session. It's gonna be TBD, right? It's kind of related, right? So here we have all of the related, related sessions in here. So yeah, I'm already streaming for 1.5 hours, right? So 1.5 hours. I would like to make a small break. I would like to make a cup of tea, and after the small break, I want to turn this into like a proper echo server, right? Into proper echo server, so it can maybe maintain several connections and stuff like that. It would be kind of nice to know like how exactly do I manage memory with this library, and I feel like this is the point. This is the point where I'll have to look into the documentation, right? Because from the API, it's not particularly clear what kind of memory management protocol is expected in here. right? So we'll probably have to look into documentation. So, but anyway, let's make some break, and we are back. So we managed to actually write something. I don't want to go into the documentation yet. I'm so sorry, but I really don't want to go into documentation. I want to try to read something. Let's try to make like a read request, right? So because that's kind of the point of the echo server, is to read something and send it back to back. So if there's a UV write, there should be what? UV read. So let's go and see if there's any UV read. So there's a reader. Okay, so there's a there's no just you. Fascinating. It's environmental storytelling, right? So there's no just a read. There is a UV read start and UV read stop. Okay. And UV read start accepts two callbacks, the allocation callback and the read callback. Damn, this is yeah, this is gonna be rough. This is gonna be rough. All right, so is there maybe there are more variants of read? So let's see. No, I don't see anything. That's the only variants of read we have. Okay, so what is the callback? It's Okay, so what am I supposed to do in this specific case? Suggested size and buffer, and I have to allocate. Am I allocating this thing, or are they notifying me that they allocated something? Like, I'm not quite sure what that callback is supposed to mean. Yes, suggested size. So I suppose you can allocate more. Maybe that's what they're saying, right? So just allocate more, just in case. Yeah, I don't know. All right, I think I'll allocate less here. I think the time has come. So the scope of today's stream: asynchronous echo server. If we manage to implement an asynchronous echo server, it's going to be called a budgeting, officially budgeting. So I think that's a really well-defined scope. But I already feel that it's going to be a little bit anal, right? It's going to be a little bit anal. But anyway, let's take a look at the documentation. Finally, after an hour, Zozin is looking at documentation. Everybody cheer. Everybody cheer. Zozin finally tries to look into documentation. It doesn't fucking open even. It doesn't fucking open. I can't open documentation. I got banned. It's sanctions. I'm sorry. The libuv documentation is under sanctions, right? So probably. Well, I mean, the fact that it doesn't load is probably banned on my side, right? Oh, it's. Looks like a start of HTML. Right, so we let's try to refresh it. So, oh, it points to the left, means like go back, right? Oh. So that's why it is better not to use documentation, because sometimes you won't be able to even open it, right? You won't be able to even open it. Anyways, as far as I know, we can build documentation ourselves, if I remember correctly, right? And by the way, so I think the documentation is actually kind of part of this. Yeah, here are the. But. Anyway, so libuv. So in the README, I remember they were talking about documentation. So here's the official documentation. So this is Sphinx. I kind of vaguely remember what the fuck is Sphinx. Is my internet down? Why can't I open anything? It's like everything is fucking banned. Everything is fucking banned. Okay. So making a docs subdirectory uses Sphinx, show different supported building options, right? So, but you don't even have a make file in here. So I probably have to... Can I just do make help? Okay. So is there anything to document? No. I don't see anything about the documentation. But then in here... Oh, HTML. No, there's no HTML. But if I try to forcefully do HTML, nah, it doesn't do that. So CMake doesn't do documentation, but maybe there's something in here. Doc. So it just gives you doc dir, and nah, it doesn't do anything. But I mean, this is probably because it's CMake. So okay, so there's some docs in here. I can see the doc. Okay. So here's the make file, all right, and it's a make file for Sphinx documentation. Okay, so is that where I can do make help? Okay, Sphinx build command was not found. All right, isn't that apogers, mind for in there? So let's x query rs. So Sphinx build. Let's put this shit in here, bravskis. Okay, Sphinx. Okay, so CMOS fix common libraries. What am I even looking at? Do I even have Sphinx? So Pocket Sphinx, docutils. So is that a right thing? Void. Maybe this is because of the void. Maybe void doesn't have shit. Okay, so query, and I want to take a look at the files that we have here. So no, we can't build documentation. Can't build documentation, unfortunately. All right, so yep. So let's just proceed without documentation, I suppose. Let's proceed without documentation. So ask LLM. I don't want to ask LLM. Sphinx doc. You suggested me to go to official website. Is that what you're suggesting? I can't open this website as already demonstrated. It doesn't open on my site, unfortunately. Says the error message. Well, I mean, that doesn't open anyway. I guess we'll have to just leave as is. Okay, I'm still not sure about these requests, honestly. I'm really not sure about all of these requests, and where do you even allocate them, how do you manage them, and so on and so forth. libuv.org, let me double check, because this thing, like, this website works by itself, but then I try to open documentation and just like it doesn't do shit. Peep has been... Wait a second, is Sphinx like a Python thing? Right, is that a Python thing? Maybe we should just install the Python thing. But as far as I know, so here's the make that stuff. Yeah, okay, so it's I was looking for actual native thing. Okay, thank you so much. So let me do that. So here's the Python 3, and yeah, we have a bunch of things. I wasn't even suspecting that it's a Python shit. Apparently it is a Python shit. All right, so GPS installed. Oops. Freaking, why my C library depends on some Python shit? Okay. Yes. It's installing some stuff, by the way. It's installing a lot. So 13 packages downloaded. Okay. Okay, help. Okay, so we found something. Okay, so let's build HTML. Okay, so what does it say? Invalid escape sequence. Okay, converting RST. Vim error. But did you generate HTML though? So syntax error. So invalid escape sequence dot. Well, yeah. Why do you have escape sequence in here? You dumbass. Like, you can just put dot in here. What else? Invalid escape sequence. Oh yeah, this one is interesting. Wait a second. Maybe... Is that because this is what I have to do? Why it doesn't like this escape sequences though? So this is a bit bizarre. Why this is invalid one? Do I have to put it like that? R, it has to be R. Okay, so let's put R in here. Okay. Okay, so it kind of worked. Thank you so much. We managed to fix that. Fucking, I'm trying to do, like, generate documentation and I still have to do this kind of shit. Okay, no theme named R found, missing theme toml. I mean, okay, sure, but can I just have an HTML? Theme toml. Okay, so anything like help? Theme? No. This is stupid. Why do I... Okay, so what about HTML? Is there any other things? Later. Tag, txt. Man. What if I do man? Man pages. Okay. Hell yeah. So there's some warnings and shit. But then, here's the man pages. Ooh, okay. So if I do man, lib uv1. How big is it? Oh, alright, we're gonna be using man pages, by the way. Man pages, right? So it's pretty good. So uv read. So can I, if I do uv read start? So, well, I mean, that's kind of bizarre. Start any. Okay. So read from an incoming stream. The UV read callback will be made several times until is no more data to read or UV read stop is called. Okay, so that's pretty cool. Changed in version 1. We start now. Consistent returns UV already. Okay, so I'm still not sure how you manage requests though. Right, so if I, but this one doesn't really do any requests, so maybe that's totally fine. UV write does a request, so UV write does a request. So write data to the stream buffers are written in order, right? So here is the logic which handles the write result. Okay, so here is the buffer. Here's a bunch of buffers in here, right? So there's a bunch of buffers. You have a bunch of requests. The memory pointed to by the buffers must remain valid until the callback gets called. So notice how they actually allocate requests on the stack in here, but I mean, there's nothing much to say in here. So is there any sections which kind of explain different stuff? So let me see. I want to take a look at the help. Do you have info? Okay, so there is a text info and run them through make info. Okay, so let's try to build the text info. Because info usually has alright, sections and stuff like that. So libuv tag ini. Okay, so I probably want to actually do info. It doesn't allow me to. Okay, so can I just open it in the terminal then? Info libuv text. Okay. CPO bash common options. Wait, I didn't. That's stupid. Run make. Do I have to really run make? That's kind of dumb. So why didn't it do everything for me? So this is the info. Okay. And this is that. Okay. So I'm just trying to see, is there any sections? Is there any sections that tell me like how to use this and that stuff? Okay, so overview. There's an overview. Nothing particularly interesting. So features. Okay. Features. Threading, synchronization. This is not convenient. I wish I could just have HTML. Oh my, this sucks. Why everything fucking sucks? Everything, I'm so tired. I'm really fucking tired of this shit. Anyways, so web. Well, I mean, they could have just gave me HTML, but they need some sort of a theme toml. Motherfucker, theme toml, can you just give me HTML? Like, theme theme error. I can't color your shit nicely, hence I'm not gonna generate you anything. Oh, it's so dumb. I swear to God, so fucking dumb. I'm tired of this shit. So it's just like touch. What if I give you theme toml? Just generate me some without a theme. Drop the theme then. Like, give me information. I don't give a shit how it looks like. I need information. Web devs. I swear to God. Web devs. Yeah, and it's just like, it's useless shit. Fucking useless web shit. Alright. Anyways. What we're gonna be doing? I will have to probably do that without all that stuff. You need to install Furo theme. I have no idea what the fuck is that. So wait a second. Can we just like query Sphinx? So rs Sphinx theme. I didn't see anything related to themes though. Markdown table stamps. I'm tired of this. Fura? What the fuck is Fura? It doesn't even exist. You're just making up shit. So there was a RTD theme. RTD theme. Okay, so let's try to install this shit. Europeans. Let me see. Man, it sucks. This kind of shit sucks. Okay. So libuv, and where's the docs, and yeah, so just give me fucking HTML, bro. Fuck off. Fuck off. Not even wasting. You motherfuckers get into the corner. Alright, so let's try to read something. Let's try to read something. I'm gonna go into uv.h and yeah, uv. Read start. So this is what we're going to be doing. I'm really not freaking sure, like, why do you need allocation thing? I'm really not freaking sure. But though, speaking of maybe in the man, we can find something. Lib uv1 uv read start. So where is it? So something about allocation, and they don't really talk about alloc callback, right? But maybe in the definition of alloc callback, that definition for callback pass to uv read start and the start, the user must allocate memory and fill in the supplied uv buffer structure. If null is assigned as the buffer's base or 0 as its length, the user must allocate memory. If null is assigned, if I assign, right, buffer will be triggered in UVDP and read callback. Each buffer is used only once, and the user is responsible for freeing it in UVDP receive and read callbacks. Oof, I see. Well, I mean, this is already useful information, by the way. Speaking of useful information. Yeah, that's basically what you have to do. That's basically what you have to do. Okay. Oh boy. So yeah, so this is the stream, right? This is the stream, and I start reading the client. Though that just means that this thing has to be allocated like dynamically or something, because we don't really know when it's gonna get deallocated and stuff. It's a little bit anal. The whole thing is a tiny bit anal. It's just a tiny bit anal, but I mean, there's nothing much I can do about it. So this is suggested size, but I didn't copy paste the whole thing in here. I didn't copy paste the whole thing. So this one, just default alloc CB. Maybe there is some default stuff provided by the library. Maybe there is some stuff, but I don't really know, and I'm not sure if I care. What's funny is that they already kind of give you the default implementation for this function, but do they even provide a default one? That's a very interesting question. Default alloc, yeah, I don't know, I don't really know. It's too much effort to even check whether they do provide it or not. It's too much effort. Right, so here's the buffer. We just allocate suggested size and so on and so forth. We might as well even trace the whole thing, right? So let's do trace default callback, and we can say maybe suggested size, suggested silence. That's what you deserve for giving me false information and wasted my time. So you get submod. So that's what you deserve. Anyways, so we do the start, and this is going to be default alloc cb, right? And this one is like, why am I allocating shit? Well, I guess I understand why I'm allocating shit. Okay, now I'm gonna go into the man, right? So let's grab this definition, and we're doing the read. This didn't copy paste it properly. Could you? Thank you so much. Okay, so this is how much was read. So called when data was read on a stream. Okay, data was read on a stream, and this is buffer. And read is the how many buffers were read. Is there data available or error? Okay, so that's understandable. That's understandable. Okay. So we can say echo back. All right. Echo back CB. So, and this is the stream on which we read all of that stuff, and this is where we probably want to send all of that stuff back. And funnily enough, I feel like what we can simply do is just this write, this simple write, where I just pass this buffer and then nread, but this one is a little bit annoying because nread is in bytes. Is it in bytes? I think it is in bytes. Then, right, when you've... It's great if there is a data available or less than 0 on error. When you reach in the file, it will be set to when less than 0, the buffer parameter might not be pointed to up. In that case, might be 0. But what is it? Fucking, is it bytes or is it amount of buffers? Okay, so the Kali responsible for stopping trying the Kali, the buffer may be null. I think it gives you a single buffer. Okay, but what is nread? Is it amount of buffers or is it amount of... What is nread? It's dumb. Okay, so what I have to do in here, so let's actually maybe trace. Trace. So this is probably just D, and so let's put it like that. So this is trace. I just want to see what is it. What is it? And yeah, so this one is going to be echo back. Echo back, and yeah, this is going to be something like that. Not equals 0. So it's probably bytes. I don't need probably. I need definitely, definitively. What is it? Tell me exactly. Is it bytes or is it just Boolean? We need to investigate. Probably is not enough for me, right? Probably is not enough for me. I need to know definitively to continue, to even continue doing anything. And that's what I'm doing right now. I'm trying to figure that out, right? I'm typing out the code that will let me figure that out. Right. Okay, so malloc, we need this kind of shit. So this is stdlib. So there's a bunch of this stuff. So the handle is like that. What else do we have? D didn't provide the D, so and red. So by its size, right, we'll be able to see what it actually is. It isn't like that, so it has to be LD. It has to be LD and used. Well, yeah. Okay, so can we now just connect. So it's doing booms, right? So let's do telnet. Okay, so did it connect? It doesn't do shit, bro. It doesn't do shit. It's useless. Fucking useless. Okay, so maybe let's actually remove booms. All right, so let's remove the timers. We don't really need the timers anymore. So let's try to recompile the whole thing. Wait. Oh, fuck. Let's remove the timers. Did I forget to rebuild? I think I literally forgot to rebuild chat. I think that's what happened. All right, so nah, it's useless. It's still fucking useless. Still fucking useless. Fuck. Okay, so let me do that. So it doesn't do shit. Telnet doesn't connect. Fuck that. All right. What we have to do? So let's take a look at all of that stuff. So we start reading, but it didn't do shit, unfortunately. It didn't do shit. It didn't. Maybe we have to specify up until which point we have to read. Maybe it's one of those things. Right, it's like I would expect at least to see something like this. And by the way, connected, I never really, did that. So another thing that I suspect is that client dies. So in a sense that like we get out of this function. Is the alloc called? Alloc was never called actually, by the way. Right, so because I provide default alloc and it literally didn't call. Alright, so just a second, let's try to run it one more time. Connect it. And nothing happened. Okay, so even though we said my hypothesis, let me finish my thought. My hypothesis is that since we allocated the client on a stack, right, and we gave the pointer to the client, that pointer is already dangling. So that's what happened, probably. So that's my hypothesis. So one thing we can try to do now is probably just allocate it on a heap. Malloc, size of client, memset. I know there's a calc. Size of client. All right, so and in here, let's do it like that. Can I just, yeah, let's leak the memory. So that's my hypothesis, current hypothesis. So memset is coming from a string. It's coming from a string, so let's try to connect. I was right. So, and this is kind of scary in the sense that if you are not being careful with this kind of shit, that means it can corrupt your stack. It was literally corrupting our stack silently. Like this shit, the fact that we allocated it on a stack, it was corrupting our stack. And it didn't even crash. This is the real scary shit, not seg faults, right? Seg faults are not scary. Seg faults are visible and actionable symptoms of a program, of a faulty program. This kind of shit is the scariest one. This one is the scariest one. Okay, so that means it answers my question, by the way, about memory management protocol. Right, so remember how I wasn't sure, like how do you manage memory? You manage everything yourself, right? So you allocate it on a heap, then at a particular callback, when something is closed, you should not forget to deallocate it somehow. So that's basically, I suppose, how it works. So interestingly, probably have to maybe de-init some of the things, or maybe shut it down, or some other things. So I remember there was like a TCP shutdown or a UV shutdown, right? So let's actually read the documentation about UV shutdown. So shutdown outgoing right side of a duplex stream. It waits for pending requests to complete. The handle should refer to an initialized stream. Request should be an initialized shutdown request struct. This is called when shutdown is complete. Okay, so what do you do on a shutdown? I suppose in a shutdown you deallocate the stream that you just allocated. Callback call after shutdown request has been completed. Status will be 0 in case of success. They don't tell you that. All right, so there's a lot of opportunity for memory leaks in here, that's for sure. There's a lot of opportunity for memory leaks. Yeah. Okay, so yes. So this is basically we're doing that. All right. So we have to do the request, right? So we have to do the request, which also, by the way, means that we can't just allocate the request on the stack. This is not something that you can do. You have to allocate that on the heap. All right, let's fucking go. So this is the request, and this is how we're gonna be doing. Maybe I should use calloc, by the way. I don't remember how to use calloc. So it accepts first the amount of elements, right? So this is one element size of request. So automatically zero initialize the whole thing. So I provide that thing. I suppose I provide the string, right? Oh, and by the way, my goal is to figure out what is nred. So let's go ahead and just try to do that. I completely forgot about that. Hello. 7. So this is essentially 5, and plus 2. I suppose it's /n/r, right? So it is bytes. Cool. Right, so Control C, and maybe I can do something like close. That's pretty cool. Okay, so yeah, so we do calloc. So then we do the request on a stream, provide the buffer, and we have to provide the amount of bytes of the buffer that we want to read. Amount of bytes of the buffer that we want to read minus, yeah, I saw that as well. I saw that as well. So this is annoying because when you're writing, I think you're writing the amount of buffers in here, not the bytes. Is that the first flow of the library design that we encounter in here? Because that's kind of weird. Yeah, that's annoying. And buffs. So it kind of prevents you from easily writing an echo server, right? Because you just read n bytes and you have the buffer. You can't just pass the same arguments into UV write. You can't just do that. So now you have to retransform that. You have to find the sub buffer, create a new buffer and pass that buffer. And in terms of memory management, okay, I allocated this buffer in here. When I deallocate it, I definitely do not deallocate it on echo. I probably deallocate it after I wrote it somewhere. Just pass 1, it's 1. Dude, don't disappoint me. Okay. So buffer len. So this is a buffer len. Just a second. Error. You just pass 1. What you're suggesting me is to tell the writer to write this size, this amount of bytes instead of this back. I want to write this amount of bytes back. So why are you suggesting me to put 1 buffer? Like, why are you suggesting me to? You suggest me to put 1 buffer of this size. That's what you're suggesting to me. Like, why are you doing that? Don't disappoint me. All right. Do not disappoint me. So we have to take a sub buffer. That's the problem in here, is that you can't just, you know, can't just pass it through. It's not passable through. It's not passable through, and that's kind of a flaw of this API. You now need to create a sub buffer. We can actually try to do that, right? So as you suggested, let's just like write it back, and it's probably going to like spam our entire screen with 65,000 bytes or something. Right, as you suggested, right? So let's just follow your suggestion. Right, so hello, and well, it didn't really, yeah. But the question is, why does it work? Okay. Well, I mean, absolute budgeting, but at the same time, why does it work though? Why does it work? Right, so why did it not send this entire thing then? Like, where... Telnet ignores null bytes? Maybe that's what's going on here. Maybe it ignores null bytes. But what if I feel like after allocating this entire stuff, where's my malloc? What if I fill it with something? Memset base with this stuff. It's a pretty valid thing to do, I think. I think it's a valid thing to do. Right. And so the answer is no, you don't just pass one thing in there. So it's not going to work. Right, so you have to take a sub buffer, and this is annoying in my opinion. This is annoying. All right, so let's give it a try. Let's give it a try. So and for the sub buffer, we can just do uv buff t, right? Sub buff, and this is going to be base buff base base. And you know what's annoying? This thing is allocated on a stack. Do I have to allocate this structure on a heap as well, just to be able to send it back? Am I not understanding something about this API? Because this looks like a bullshit. This is like, why do I have to do that? Why do you even have to do that? That's like, doesn't make any fucking sense. Yeah, because it's definitely gonna, like, I don't want to allocate that structure on the heap as well. Like, that's just straight up bullshit. That's just straight up bullshit. So that's annoying as fuck. Holy shit. And I can't even, okay, so I can't even reset the whole thing. Let's try to see, maybe stack allocation will do the magic. Well, I mean, it may potentially work, but then it will suddenly corrupt something on our stack. On the other hand, wait a second. No, it just performs the request. It just performs the request and then it continues. It's probably going to be attached to the request, unfortunately. So there is a write request, right? So there's a write request, and uv.h, here is the write request. Let me find it. So here it is. Does it have a buffer attached to it? So the callback. So the write private fields. Maybe it has a. Maybe it's in the private fields, but I doubt that. So data reserved. My only hypothesis is that it doesn't save the pointer to subbuff, but right away takes these values and copies them somewhere. I will literally have to look into the documentation of this thing, like into the implementation of these things, because I don't know how else can I answer this question. Compile with undress and maybe this is something that I should do. Okay, so oh my god. Okay, so if I try to just do that, it probably stop asking questions. Emacs, don't ask me questions. I don't care. Okay, so there's this stuff. Of course. Okay. So here's the bunch of buffs. check before write. Okay, cool. Request initialization of the request, by the way, happens by this operation. Okay, cool. So here is the buffers, buffs SML. Okay. The request allocates its own buffers. Oh my god. It copies them into the request. Okay. Man. All right, so it's totally fine. So the buffers are part of the request, and it literally copies them inside of it. So now I'm fine, right? So my heart is at peace. So we can literally do that, and it's totally fine because it will copy that into anything. All right. So then we have a write CB. All right. So here is a write CB. And I don't really know what else do we do with this thing. Like, how do we deallocate this request? Do we just like free this thing? Right. Maybe there is a, I don't know, free request, right? So this is the callback. That this is annoying in the sense that it has to accept the right thing, right? Right CB. So let's just keep it like that then. Okay, so let me rebuild the whole thing now. So it just has that status. Right, so in a malloc, we actually keep this thing like that. We allocate and we fill it with CCs. So if there's anything wrong, we instantly see the garbage on the screen, right? So let's give it a try. Let's try to run the whole thing, and maybe that will do the trick. Just a second. Telnet. Okay, hello. Got hello back. So that's what needs to be done, right? And that's what I don't like about this API. I think this is a flaw of the API. The fact that I can't just read the data and sort of like pass it through immediately. But maybe the library was literally not designed for such a simple use cases. It was designed for heavy lifting duties, you know, like developing Node.js and stuff like that. And so because of that, this kind of use case is not taken into account. Right, so because it was literally designed for Node.js, right, as far as I can tell. Okay, and probably we leaking something and maybe touching some memory in inappropriate places, but overall, I think that's basically what we want to do. So yes, somebody suggested to actually do the sanitizer. Right, so let's actually do clang f sanitize memory. I think this is how we do that, right? So let's just try to do that, and hopefully it will crash immediately if something is wrong. Hello, world, and then I close the whole thing. Okay, then okay, at least nothing really broke, right? So we didn't touch memory in any way. Oh, it's address. Okay, so sanitize address. Let's go. All right. Hello, world, close. Okay. So also, we're probably not cleaning some stuff properly. And by the way, we can also try to do like multiple connections. Let's do multiple connections. So telnet. Telnet, telnet, telnet. Okay, hello, foo. Bar test your mom test hello, and it keeps allocating shit, by the way. This is a little bit scary. So it keeps allocating things, but now we can close some of the stuff. It already works, right? So the memory management of this library is kind of questionable. It is kind of questionable, but it already works. Right, it already works. And I'm already streaming for 2 hours, right? So I think I'm gonna actually stop it here, right? I think I achieved everything that I wanted to achieve for today. So it's kind of crappy, right? But going over this entire code and making sure that we don't leak anywhere is kind of too annoying to continue, so I don't really want to do that. Right, I can achieve what I wanted, right? So this is a synchronous echo server. It is leaking as hell, but it works, right? So it works, and so that means the goal has been achieved. What is fsanitize? So like Clang comes with a bunch of sanitizers, right? So that check different things and stuff like that. So for example, if you try to use uninitialized, you know, value or whatever, I think it will tell you that. I don't remember. I think if you try to, maybe it's not a sanitized address, but so essentially a bunch of like linters, checkers, sanitizers that also add a little bit of a runtime, and yeah, I think it's an undefined that will do that. Yeah. So if I try to do something like that, it's not going to complain, I think. Well, I mean, it's going to complain compile time at least. But if you also add undefined behavior, undefined, right? So, I didn't complain, by the way. It's kind of weird. I should have complained though, but probably because I freaking know this was not initialized. But yeah, it's sort of like a linters and stuff like that. So yeah, interesting library. Interesting library. So do you guys like it? It's kind of cool. It has a bunch of flows, but I think maybe you can kind of get used to it. Personally, I kind of liked something like libmil more. Right, so it's basically also a synchronous library, but it's more, yeah, so it's designed more for convenience when you're programming in C. So it has coroutines and stuff like that. I feel like this library was kind of designed to be wrapped around for JavaScript. That's probably what it was designed for, right? So you just like kind of develop the lower layer once, right, and kind of forget about it. So that's what it's probably designed for. So, but anyway, I guess that's it for today. Thanks everyone who's watching right now. I really appreciate that. Have a good one, and I see you all on the next recreation programming session with who I Mr. Azus. So love you all.